THAAD is a crucial component of the U.S. effort to deploy a multi-layered, integrated ballistic missile defense system. The system's high-altitude intercept capability reduces the impact of enemy weapons before they hit the ground, and its non-explosive kinetic effect minimizes the possibility of detonation. This air defense system is highly effective for countering ballistic missile threats. The UK-based company, BAE, said that the next generation of infrared seeker technology would offer vital targeting capabilities to shield the United States and its allies from ballistic missiles. THAAD is a highly effective system for mitigating high-speed missile threats, and we're making it more capable, BAE Systems Precision Guidance and Sensing Solutions Director Greg Procopio said in the release. The press release continued that the THAAD Seeker gives the ballistic missile system, which can intercept missiles inside and outside the atmosphere, crucial sensing and guiding capabilities. BAE Systems is developing the THAAD Seeker at its electronic systems facilities in Endicott, New York, Huntsville, Alabama, and Nashua, New Hampshire. The Seeker uses sensors to lock onto approaching ballistic missiles, traveling up to 17,000 miles per hour, allowing the missile guidance system to direct the THAAD interceptor to the threat. The THAAD Interception. The THAAD missile system is developed to defend against hostile incoming threats like tactical and theater ballistic missiles. The system can operate over a 200-kilometer range and 150-kilometer altitude. It consists of the top layer of a layered defensive shield to defend valuable tactical or strategic sites. These sites might be places like population centers or airports. The system can intercept both exo-atmospheric and endo-atmospheric threats. The THAAD battery typically uses 2 Mobile Tactical Operations Centers, TOCs, 9 launch vehicles holding 8 missiles, and a ground-based radar, GBR. Each missile in the system is 6.17 meters long. Each missile has a single-stage, thrust-vectoring solid-fuel rocket motor that weighs about 900 kilograms. A typical THAAD battery has 9 M1075 truck-mounted launchers. The system's launch vehicle is an Oshkosh Truck Corporation heavy tactical truck with expanded mobility that has been modified. It takes about 30 minutes to reload the launch vehicle. The ground-based radar, GBR, used for surveillance, threat classification, and threat identification is the Raytheon System's anti-PY2 radar system for the THAAD. This missile interceptor can also be combined with military surveillance satellites like Brilliant Eyes. The missile defense system recently grabbed attention due to its possible additional deployment in South Korea, which enraged China. THAAD Air Defense Missile Program. The U.S. Army is expected to acquire 80 to 99 THAAD launchers, 18 ground-based radars and a total of 1,422 THAAD missiles. 2 THAAD battalions are planned, each with 4 batteries. In 1992, Lockheed Martin Missiles and Space and other industrial team partners were awarded a $689 million contract to develop the THAAD system. Raytheon was selected as subcontractor to develop the ground-based radar. Raytheon is responsible for the solid-state receiver transmitter modules, while TRW is responsible for software development. The other main contractors are Raytheon for the traveling wave tubes, Data Tape for the data recorders, and EBCO for radar turrets. The THAAD program entered the Engineering and Manufacturing Development (EMD) phase in 2000. In May 2004, production of 16 flight test missiles began at Lockheed Martin's new production facilities in Pike County, Alabama. Flight testing at White Sands Missile Range, New Mexico, of the EMD system began in 2005. The first flight test of the entire system, including missile, launcher, radar and fire control system, took place in May 2006. Flight testing began at Pacific Missile Range, Kauai, Hawaii in January 2007, with a successful intercept test in the high endo atmosphere. A second successful test took place in April 2007, with intercept in the mid-endo atmosphere. The final White Sands test took place in June 2007, with a low-endo atmosphere test. In October 2007, THAAD performed a successful intercept of a unitary target outside the atmosphere, exo-atmospheric. In June 2008, THAAD successfully intercepted a separating target in mid-Indo-atmosphere. Until the end of 2011, THAAD has completed 9 intercepts and 12 flight tests. THAAD versus ICBM. A ballistic missile in its terminal descent phase offers an interceptor system only a very small window in which it can be shot down before it detonates its warhead. A THAAD interceptor flies at Mach 8, more than 3 times the speed of a rifle bullet, and can hit target up to 150 kilometers high. However, this is still not fast or far enough to reliably hit ICBMs. The farther a ballistic missile is designed to go, the higher and faster it must fly. This means that super long-range ICBMs travel at speeds around over 20 times the speed of sound and can fly up to thousands of kilometers above the Earth's surface, making them much more difficult to intercept than shorter-range ballistic missiles, even when diving back to the surface in the terminal phase. To have a good shot at an incoming missile, interceptors of comparable speed are preferred. This does not mean interception by slower missiles is strictly impossible. THAAD is claimed to have a limited capability for low-altitude ICBM interception. That is to say, it can try, but the odds of success would likely not be high. Another issue is that THAAD has an effective range of around 124 miles and possibly less versus an ICBM threat. While that suffices for defending a geographically confined area like the Korean Peninsula, across the sprawl of North America, 2 THAAD sites would mean defending just 2 metropolitan areas. So, hypothetically, the Los Angeles and San Francisco areas might receive the extra protection. At any rate, the latest Hwasong-15 rocket demonstrated sufficient range to fly across the continental United States, so a missile attack could simply be targeted at cities without THAAD. While this might have the benefit of making the closest, most densely populated cities less attractive targets, it would not help that much in protecting the nation as a whole unless batteries were deployed around all major cities. And that's only assuming THAAD provides a useful ICBM defense in the first place. Lockheed has proposed creating a THAAD system with an improved seeker and a 2-stage rocket, giving the interceptors 3 times the range. Supposedly, it could be operationalized in 4 years. While THAAD might conceivably have its ICBM intercept capabilities improved, THAAD and other upgrades exist only as design concepts for now.